So I got this display. It's been so long since I ordered this kit, I don't even know what the hell it is. I thought it was a measurement, but it's apparently some type of a clock. With no damn directions whatsoever. Is there something on the board? Frequency counter, crystal tester. So let's see what we got. We got these resistors. I think I should just start here and go across. So they have a transistor. See, I need some solder. I need some lead clips. I need this to be able to see. And that's probably going to be it, considering there's no directions to mark anything on. So here's a transistor, 9014, 9014. And placement would be the flat side by the flat side. So let's just go ahead and get started. There's some tribulation about this, by the way, without directions. I like to leave those standing up quite a bit above the board. So I'm just going to put that like that and start soldering. And I always check and clip. So we'll just keep working our way across there. 4148. You have to know the symbols. That's a diode. 4148 should be one of these. Also, IN914, it's the same part. And the strip side goes on the strip. So you can pre-bend the leads. Bend those back to hold it in place. It will slowly come together. Rather than search for a resistor value, I'm going to find what value this is, and then I'm going to figure out where it goes. Apparently somewhat large. 100K. So I need to find where 100K goes. 100K. Not like there's directions or anything. Put that down like that. Bend the leads a little. Solder it in place. That looks good. Flip it. That's good. Now let's just keep going with the resistors for right now. I move those to the side just to make them hold a little better. That's not absolutely necessary, but it does help get a good placement. They all look perfect. There we go. Very neat looking. Okay, so what should we do next? There's a little power connector. I'm gonna have trouble finding a 9-volt that'll fit that. Wondering if I shouldn't leave that off for now. Decisions. I'll put it on, and if I have to, I'll solder to the back of the board. I'll look through my wall warts and see if I can't find something to fit that. Okay, moving right along. Now they give you this, and I'm assuming that that is going to be for the crystal. Let's just take one of these capacitors and see what it says. It says 22, and right there I see a nice 22. I want to bend the leads, of course. Okay, that's enough. Let's go ahead and do some soldering. In case you're wondering, I'm using a 30-watt soldering iron, non-adjustable. It's also brand new. This goes here, and there's a flat side, and the flat side goes down. Okay, I keep a piece of styrofoam here, so I can prop that up. There's a taller component keeping it from sitting on the table. I gotta tell you, there's no single component on here that's difficult. You might look at the whole thing as difficult, but in reality, there's nothing on here that's difficult. 9018 goes right here, and the flat side goes toward the top of the board. I'll just feed these in. Look, and I like to have them stand up. Kind of irrelevant, I just kind of like it that way. I also like to clip as I go. Okay, 20 meter, I'm sure, is this crystal. 20 megahertz, not 20 meters. It used to be in a ham. 20.0 SDX. I'm going to take that as 20. Let's do another 4148 right here. The band goes on the white side. On a board like this, if you mess something up, cut the part off and get it out, because if you try to get the part out and save the part, it'll tear up the board. And then get another part. Except for maybe what's on here, you probably have most of it on hand. Okay, so another transistor. 7550. So I'll go ahead and spread these a little. 7550. I saw that earlier. 7550. And the flat side goes to the bottom of the board for this one. Looks good. There we go. Getting closer. Don't have a lot of parts left. I have another 22, but there's no 22 on here. I think they gave me a 22 instead of this 102. Okay, did you ever make a socket for a crystal? I keep these SIPs, single inline package. Keep these SIPs, and I just break off 3 of them, and I take a pair of very small dikes, cut the middle pin out, and I can put this in as a socket. And there's just a little nub to solder on too. Crystals are finicky. So there you go. Now I'll cut, once I get this working, I'll cut that shorter, but that'll work. Okay, I'm really running out of parts. I'm reasonably sure that this switch goes right here. I feel like I'm playing a game of blindsman bluff here. Trying to get somewhere without knowing where the hell I'm going. Ah! Snapped right in. Excellent. Snapped right in. Once it snaps in, it's self-holding, so it'll stay in place while I solder it. I'm thinking that's a reset switch, maybe. Well, I'm pretty much out of parts that's labeled. I'm hoping that 102 they don't need. It's a filter for the in, so without that being there, that's going to come in, your signal in. It's not going to go anywhere. Well, a little bit more research is going to be required for this, but we can do what we can. And we have a socket for the pick, and pin 1 is this way. There's a little indentation there. Make it match the board. Definitely going to need the styrofoam for this one. But what I can do, hold it down so I know I'm getting good coverage. Okay, solder both corners. Now I can put it up on this. And when I get it on here, a lot easier to solder. Just enough solder to make a good electrical and mechanical connection. Let's see how that looks. All of those are perfect. Now, if I'm soldering a kit that has a chip like that, I'll leave that chip out of the circuit until I'm done with everything else. So the only thing's missing is this 102 capacitor. Okay, so I finally found these SIPs, and one of them will go almost all the way across. So I just need 5 for the other one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5 and 5. Okay, so what's going to happen is I'm going to go ahead and put these in. They're going to stick off the board quite a bit, but it'll allow me to use them on another project. I don't want to solder them onto this one because with these missing components, I'm not sure this is ever going to work. If it does work, hey, I'm lucky. If not, I got these for another project. That's going to work out well. So put this back on. Lay that on the table. Start soldering it again. I like this a lot better. Now it's odd to me that they're made provisions for some type of an additional connection. Now these will come off. Maybe not easily, but they'll come off. Since I soldered them with them in, they should be lined up. Oh, looks like I smashed that crystal. Well, let's cut that baby down a little anyway. I still have it protrude some, but and these 3 sockets, which I think go right here, I'm actually going to make my own that's 4 to cover that last one. I made this 4 socket. I'll put that in place, and somehow I've got to solder that. So I got one that holds it in place. There we go. It's always possible that that 3 was not meant to go there, but here. So I'm going to go ahead and put it there. It's not going to cost me anything to put it there. And I don't have to come back later and do it. Okay, all the soldering is good. Now, I know that this isn't going to work in terms of reading in a signal because the in signal goes through that capacitor that's missing. I've only got a 22, and that says 102. So, let's go ahead and wire this up. Insert the chip, and that did not go on right at all. A lot of new chips to get in the socket. You have to squeeze the pins together a little. So I got the back pins in the socket. I'm actually going to squeeze the front till it goes in. There we go. And pin and the notch in the front matches the notch on the board. So all I need now is 9 volts. DC 5 to 9. Ooh. 5 to 9, so I probably should get a 5, but that is so small. I don't know if I have something like that or not. I have a Power Light adjustable power supply. It's not your typical adjustments, but it just has set values. So let's go with 6 volts. I'm okay with that. Now, let's see if we can test this. 6.24, and it says between 5 and 9. I'm okay. First power up. See what happens. It's working. I really need to get a user manual for this. So it is working. It's just without a user manual, I don't know what that's supposed to do. Well, I'm back to finish this. I did a little research, and that 102 is a 0.001 microfarad disc capacitor. So I can go ahead and do that one. This is out of my spare parts bin. So it's not going to be perfect fit maybe. There we go. That's going to be okay. Bend those leads just a little. Now, always tin your soldering iron. My power supply. Oh, it's reading that crystal. It's a little weird because that's 3579 and that's 4 megahertz. So something's not working right. Ah, it's at 3975 there at the very end. Maybe. Okay, so that's 3579. It appears to me that hand capacitance is coming into play. Okay, so I figured out that it works. Need a better power plug. It looks like the power plug is a bigger hole here. That is an odd one, by the way. I might just end up soldering a 9-volt supply right to the back of it. But I obviously need to get a case. It's put together, it works. And this is a 0.001 capacitor. Didn't come with the kit. They gave me an extra 22. Technically this is 1 picofarad and this is 22 picofarad. No big deal. I had it on hand. If you don't have it on hand, you'll have to buy some. That's a bummer. Soldered together fairly well. Probably need to get some acetone and wash off some of the flux, but looks in good shape. So if you like the videos, please subscribe to my channel. Thanks for watching.